Okay. So what we're going to do is in this video, we're going to do another U substitution. Okay, so we're going to use substitution again, but this time we're going to have to do something else. We're going to have to change some things around because if you notice, if you look in here, we got a trig function, cosine squared theta. Well, you don't have any sign anywhere. So this is going to make it difficult to do a U substitution if we don't have a derivative of cosine anywhere. But that's okay because we've got some trig identities that we can use. So what we're going to have to do is we're going to have to replace this, rewrite this expression using trig identities to get something that we can use. So let's do that. Okay, so there's the identity we're going to use. Now notice how I used an identity that got the square out of there. So now it's 1/2 1 plus cosine 2 theta. So I got the double angle here. Okay, that's going to help us. So now, if you look at here, if I see this, right? I can use this as my u, and then my du is just going to be 2, and that's going to be fine. Okay? So now let's do that. So let's substitute in 1/2 times 1 plus. Okay, so what we're going to do is we're going to make u equal to 2 theta, du equal to T2 d theta, and of course so then of course I'm going to multiply just to break this off here. So this is going to be 1/2 du equals d theta. So what I'm going to do is I'm going to distribute the 1/2 and break this up into 2 pieces. So this is going to be 1/2 plus 1/2 d theta. Okay. No problem there, right? So just simplifying it. Now, the limits of integration though. Well, we haven't done a U substitution yet, so let's just keep it the way it is. So u pi over 2. Okay, so now what I'm going to do is I'm going to split this up. So I'm going to write this as 1/2 Okay, and so now, what am I going to do? I'm going to integrate this. Now, we can integrate the first one as is. Right? There's nothing wrong, because this is just 1. So I can integrate this easily. So I don't have to do any U substitutions here. So I'm just going to write this as 1/2. And it's just going to be the integral of that, which is just going to be theta, right? So it's going to be theta from 0 to pi over 2. So, okay, I'm not going to do anything there. But here, I'm going to use my U substitution. Now, I'm going to write this as 1/2. And now my limits are going to change once I do the u substitution. So I'm going to rewrite this as well, if I'm going to use a u substitution, I'm going to go cosine u and then 1/2, right? So 1/2 du. Okay, and so this 1/2 is just going to come out, and this is going to become a 4th. And now my limits of integration are going to change though, because if this is 0, if theta is 0, u is 0. So that doesn't change. If theta is pi over 2, u then becomes what? Pi. So now I'm going to go from 0 to pi. Okay, and now I'm going to rewrite this. And so the integral of cosine is what? Sine, right? So this is going to be sine u evaluated from 0 to pi. Okay. So far so good, right? And now all we're going to do is now evaluate this. Okay, so what is this? This is going to be 1/2, so this is going to be 1/2, and then I'm going to evaluate it from 0, 0, and pi over 2, so it's going to be pi over 2 minus 0, right? Plus 1/4 times sine of pi minus sine of 0. Okay, so what does this equal? Well, this is just going to be, well, pi minus 2 minus 0, that's just going to be pi over 2 times 1/2, which is pi over 4. Plus, well, what's sine of pi? 0, right? What's sine of, oops, not theta, 0. Sine of pi is 0. Sine of 0 is 0. So this whole thing just goes to 0. And so we just end up with pi over 4. And that's the answer. And that wraps up this section for substitution. Okay, have a great day.